on my graph, and I'll do my graph in red, I'm going to put an open circle here, and I'm going to make it come in from the left to there, and then, and then from the right, it needs to come there also. Now, I don't know anything else about my function, do I? I mean, that's about it. Would you all agree that that little red graph right there would have a limit as x approaches -2 of 3? From the left and right-hand sides approaching the same place. Now, why didn't I fill it in? Yeah, in the given information, it tells me nothing about the function's value at -2, does it? Well, not in part 1, but look at number 2. What does it say at f of -2? It needs to be 0, right? That means at -2, my function's height should be 0. So what should I put? A point where? At -2, 0, on the x-axis. See, that's why it would have been incorrect to fill that circle in. Does that make sense? All right. Now I need the limit as x approaches +1. So let me put +1 on my axis here. There's 1. I need from the left-hand side for it to be approaching where? -1. So here's -1 on my y-axis. So what I'm going to do is I'm going to put solid dot or what? Open here. And from the left, it needs to be approaching that, right? So from the left, I'm just going to draw a little tail coming off my dot, or my little open circle. The next one says that as I approach 1 from the right, excuse me, from the right, I should be approaching what y value? 2. So I'm going to go draw up at the y value of 2 and an x value of 1, another open dot, and that's where I'm supposed to be headed coming in the right side. And what is my function's value at 1 supposed to be? 2, which means I should do what? Fill in that little circle up there. Now, let's move on to the 5th one. I just realized that I have number 1, then number 2, then number 2. Like I wrote 2 twice. Do y'all see that? Sorry about that. I'm on number 5 now. The limit as I approach 4 from the left of the function should be headed to where? Infinity. So let me first get 4 on my axis. 2, 3, here's 4. And because I'm headed to infinity, I'm actually going to put a vertical asymptote in there just to let everyone know what's going on. I'm supposed to be headed over towards infinity there, right? Positive infinity means up forever. So my graph should be doing this. Right? Where am I supposed to be headed if I'm approaching 4 from the right? Headed towards 0. So how do I do that? On the x-axis at 0, right? Put a what? Solid or open? Open. Open. Why not solid? It's not necessarily because it's not asymptote. Look at number 7. It says at 4 we're undefined, right? So that means that you can't fill it in with a dot or else you've defined it, haven't you? And I'm supposed to come out the right side headed towards that, right? That's it. Now, I need to fill the rest of the function in, but that's the basic structure based on that information. How I fill in the rest, that's up to you. All right, you can, I mean, there's going to be infinitely many possible answers here depending on how you draw it, but everyone should have that basic structure. So I'll fill in the rest. Let me fill in the rest with black just to show you how I could draw it. Like I could make the right side come out and do this, you know, make it go up if I want to. I could make this thing go up and then come back down and join in like this. I could join these two pieces like this. And on the right side, I can make that go up, and hell, I can make it go back down. It doesn't matter. So everything I've put in black was kind of up to me. But that function has all those characteristics. Could I have done this? Look at the right side of the graph. I'm going to do something. Erase that. Could I have done this? Why not? It's not a function anymore. Vertical line test would fail. So just make sure, as long as when you're filling all the other stuff in, just make sure your function is a function at the end of the day. So I'd do something. Pardon me? The green dotted? Because on number 5 it says that as I approach 4 from the left side, my function has to head to infinity. All right. That's pretty much it for 1.3. Now I had put here on this thing, I have the homework problems and stuff for all the sections, but I'll put that back up at the end of class, okay? All right, now we're going to move on to 1.4. 1.4 is a pretty meaty section. There's a lot in here. It's basically saying this, though. So far, all we've done is looked at limits of functions using the graph, right? I give you the graph, and you should be able to tell me where things are headed. Or if I tell you a bunch of information like this example, you should be able to somehow construct a graph from it. In 1.4, we're given the function, the algebraic function, and we're asked to find the limit without any pictures. And this is where the algebra within calculus begins, all right? And I've always told all my students, especially if this is your first time ever taking calculus, calculus is algebra on steroids. I mean, there's algebra in this class that you didn't even know was possible. So be ready for that. It comes kind of quick. All right. So I'm not going to go through all the notes here. I will bring them up here on my screen real fast. Chapter 1. So there's, that's me basically saying, hey, now we're going to need to do some algebra. And then here are a bunch of laws and rules on taking limits. And they're all in the book. I'll refer to them as I work through problems today. There's this direct substitution property, some other stuff, and we're just going to get right into some stuff, all right? So I'm going to start working out of the book. I'll write the problems on the board, but if you want to open your book, I'm on page 44. I'm going to start working through even problems, and then you'll do odds for homework. So let me start page 44, number 4. So it gives you the limit. X approaches -1. And then in parentheses, x to the 4th minus 3x times x squared plus 5x plus 3. So the question is, what happens to this function as you try and let the x value get close to -1, right? That's what the limit means. Get close to -1, but don't actually be -1. The first thing we always do with any limit is see what happens if we just try and let x be -1. Let's just see, just plug it in and see what happens. And there's properties in here. If you have your notes in front of you, I'm looking at 1.4.4. It's called the direct substitution property. It says if your function f is a polynomial function, a rational function, a trig function, an exponential function, or a log function, then as long as a is in the implied domain of f, we have that the limit is just what you get when you plug A in. Direct substitution. So when you look at that up there, is that a polynomial function? Yes, if you multiply all this out, you get a polynomial, wouldn't you? So I have a polynomial function, so I'm going to go ahead and just plug in -1. So the correct way to write this is this, equals, now since I am going to, at this point, plug -1 in for x, I do not write the limit anymore. Okay, I just plug in, so I'm going to write -1 to the 4th minus 3 times -1, -1 squared plus 5 times -1 plus 3. And all we have to do now is evaluate this, figure out what it is. So what's -1 to the 4th power? +1. What's -3 times -1? +3. And then what's -1 squared? 1, and then -5, and then +3. So we get 4 times what? -1, which is -4. That's direct substitution. Nothing to it, just plug in. You're allowed to do that if this is a polynomial function, a rational function, exponential, log, trig. All right? Let's go to number 6. Now they switch up with variables here. Limit, instead of using x, they're using u. U goes to -2 of the square root of u to the 4th plus 3u plus 6. So is this a polynomial function? Well, what's underneath the root is polynomial, right? But then you have a square root, so that's no longer technically a polynomial. However, if you look at, let's see, look in 1.4.2 and look at property 11. It says that if you're trying to take a limit and you have a square root or any root, right, that you can basically put the limit inside the root and take the limit of what's inside. So I can essentially turn this into being equal to the square root of the limit as u approaches -2 of u to the 4th plus 3u plus 6. And now I'm taking the limit of a polynomial, right? So I can use the direct substitution property. So what would you get if you plug -2 in there? Square root of -2 to the 4th is what? 16, right? I'm doing one at a time. -2 to the 4th is 16 plus 3 times -2 is -6 plus 6. Y'all follow what I did there? Okay, and what is that? 4. Okay. So you get 4. When did I stop writing the limit? When did I stop using that notation? Right before I plugged in, right? And you need to remember that. The limit is always in your work until you plug in. Once you plug in, the limit needs to go away. The square root is 16, which is 4. Because the 6's cancel, you have 16 under the root still. right? These are gone. Square root of 16 is 4. All right, number 8.